Peace be upon you all. My name is Maged Kamel and I am a civil engineer. We will include in our discussion the following points. Number one, how to draw Mohr's circle of inertia from given 2 points. That is the case of Ix is bigger than Iy. Number two, how to find out that Mohr's circle is shifted by a value of 1/2 multiplied by Ix plus Iy. Number three, what is the principal angle to theta sub b in Mohr's circle of inertia? Number four, what is the value of Lu, of Iu and Iv in Mohr's circle of inertia? Where are the points? Number five, where is the pole point in Mohr's circle and in the normal view? From the previous post, we have 3 equations for Ix dash, Iy dash, and Ix dash y dash as shown in the slide. The 3 equations represent 2 points on Mohr's circle of inertia, which is a shifted circle drawn with the x-axis representing the values of the moment of inertia Ix and Iy. The vertical axis represents the values of Ixy, or the product of inertia. The circle is shifted to the right from the vertical axis by a value of 1/2 Ix plus Iy. I have drawn an axis. First, in the case of Ix value being bigger than Iy value, how can we draw Mohr's circle of inertia? We start to locate point x with a coordinate of Ix, Ixy as positive values, and there is another point which is point y that has a coordinate of Iy, minus Ixy. Joining these 2 points will intersect with the vertically shifted axis at the center of the circle. The radius of this circle equals to the square root of Ix minus Iy over 2 squared and the square of Ixy. We can represent x-axis as the axis joining point x with the center of the circle, while the y-axis as the axis joining point y with the center of the circle. We have axis x dash, which can be obtained by joining the center of Mohr's circle of inertia by point x dash, which has a coordinate of Ix dash, Ix dash, y dash. The opposite point is point y dash, which has a coordinate of Iy dash, minus Ix dash, y dash. The enclosed angle between axis x and axis x dash is 2 theta, which is twice the value of the theta from the normal view, from which we obtained the 3 equations Ix dash, Iy dash, Ix dash, y dash. Since Mohr's circle of inertia had both points x and x dash, and that concludes that the radius of the circle can be also obtained by the square of the value of Ix dash minus Ix minus Iy over 2 plus the square of Ix dash, y dash value. To prove that the Mohr circle is shifted, we want to check the sum of the square of Ix dash minus Ix minus Iy over 2 plus the square of Ix dash, y dash will be equal to the sum of the square of Ix minus Iy over 2 and the square of Ixy. From equation 1, if we deduct from the 2 sides the value of Ix minus Iy over 2, we can use the term A as equal to Ix minus Iy over 2, while B term equals Ixy. Ix dash minus 1/2 Ix minus Iy equal to A multiplied by cosine 2 theta minus B multiplied by sine 2 theta. For Ix dash y dash, its value will be equal to A sine 2 theta plus B sine 2 theta. We will move to the next slide. Square ix dash minus 1/2 ix plus iy will give a square cosine square 2 theta plus b square sine square 2 theta minus 2a by b by sine 2 theta by cosine 2 theta. While squaring ix dash y dash will give a square sine square 2 theta plus b square cosine square 2 theta plus 2a by b by sine 2 theta cosine 2 theta. From the next slide, adding together will give a squared plus b squared, which will be rewritten as ix minus iy squared divided by 4 plus ixy squared. This value represents the square value of the radius represented by the square of the distance of Mohr circle of inertia and point X. We will move to the next slide. We can check what is the value of the square of iy dash minus ix plus iy over 2 plus the square of ix dash y dash will give. Using the same terms a and b, we will proceed to equation number 2, and we will deduct from both sides the value of ix plus iy over 2. The new right-hand side can be written as equal to minus a multiplied by cosine 2 theta plus b sine 2 theta. From the next slide, adding together the square of iy dash minus ix plus iy over 2 plus the square of ix dash y dash will give a squared plus b squared, which we will rewrite as ix minus iy squared over 4 plus ixy squared. The result matches with the radius value from point X and the center of the circle. Moving to the next slide, slide number 7. The point of maximum value of inertia is point capital Z, where ixy value equals 0. What about the direction of the principal axis? The direction is obtained from Mohr's circle of inertia by an enclosed angle of 2 theta b in the clockwise direction from the x-axis, while in the normal view it has an angle of theta b from the x-axis in the clockwise direction. Moving to the next slide, slide number 8. The point of minimum value of inertia is point capital Z dash, where the product of inertia ixy value equals 0. What about the direction of the v-axis? The direction is obtained from Mohr circle of inertia by an enclosed angle of 180 minus 2 theta b in the anti-clockwise direction, or 2 theta b from the y-axis in the clockwise direction, while in the normal view it has an angle of 90 minus theta b from the x-axis in the anti-clockwise direction. Moving to the next slide, slide number 9, the value of 2 theta b can be estimated from the third equation by setting ix dash y dash to be equal to 0. This will give tan 2 theta b value as equal to minus ixy over ix minus iy over 2. The negative sign will include that the angle is in the clockwise direction. From the next slide, the value of Imax or IU can be estimated as equal to the shift, which is Ix plus Iy over 2, plus the radius value. Checking the tan 2 theta b expression, we can draw an angle and get the radius value in terms of Ixy, Ix, and Iy. From the next slide, the value of I minimum or I min or IV can be estimated to be as equal to the shift, which is ix plus iy over 2, minus the radius value. Checking tan 2 theta b expression, we can draw an angle and get the radius value in terms of ixy, ix, and iy, and deduct the value of ix plus iy over 2. From the next slide, the pole point in Mohr's circle of inertia is the point from which you can get direction, and the center of the radius is the pole point. When we join to point x, will give the x axis, while joining with point y, you can get the y direction. Similarly, a line from the center of the circle to point capital Z will give the principal maximum direction or the u direction. From the last slide, we can get the pole of the normal view as point Z dash, joining the mirror point of x, which will give the u direction in the normal view, and join to the mirror of point y will give the v direction. Thanks a lot, and peace be upon you all.